So, good morning, everyone. So, I will talk about the GREENVELOPES project. So, this is a French-German project on carbon and heat and water exchanges of building green walls and green roofs. So, the PI of the project are Cécile and Stephan Weber. No? It does not change the slide. So I will present first the objectives of the project, and then the experimental sites and the very early results on model. So the objective of GREENVELOPES, the first objective, is to improve our understanding on the exchanges between roof and walls, green roof and green walls with the atmosphere. So, and to do this, there will be long-term measurement sites and also modeling. So the second objective is to include these processes of green roofs and green walls in the TED model to be able to do a physically based evaluation of strategy using these adaptation strategies. So about green roofs, there was already the PhD thesis of Cécile that was done that allowed to implement the green roofs on the roof of TED, including a complete vegetation model on the roofs. And the heat exchanges also with the wall below and with the canyon and the atmosphere. For the green walls, there is everything to do because for the time being, there are parameterization of strict trees in TED, so that we have the low vegetation in the canyon, we have the strict trees in the canyon, simulated as a layer of trees, but there should be some necessary changes to implement this as green walls, especially for radiative interception, for example. So that's the second objective. And the third is then to quantify microclimatic regulation and CO2 sequestration at city scale of such adaptation strategy. So there will be some scenarios that will be done for the cities of Toulouse and Berlin. So Toulouse in France and Berlin in Germany. And then using the TED model, we will evaluate the impact on water needs also on CO2 sequestration and urban environment mitigation. So there will be then three scales. One, to study the processes at the vegetation and building scale, mostly based on the observations. Then one at the street or neighborhood scale in modeling with TED, and then at city scale. And the time scale will range from early to seasonal and annual scales with also long-term measurements and microclimate, and we will assess microclimate, water, and CO2 aspects. So I switch now to the experimental sites. So first, the green roofs. There are two green roofs in Germany that are heavily instrumented, one since 2014 on the airport of Berlin, and another one much larger, almost 1 hectare, on Obenburg, storehouse in Obenburg. And this, with on the measurements, there are also, of course, meteorological measurements, but also surface energy balance with net radiation, radiative fluxes, turbulent and sensible heat, and also, of course, CO2 fluxes. And all these data will allow to validate the model. So here is an example of measurements from for first year of measurements, so 2014, 2014, 15. on the x-axis, and then you have the hour on the y-axis, and this shows that during nighttime all year, and during winter time you have an emission of CO2 because of the respiration of the soil, substrate, and of the vegetation. While during the day in warm season you have photosynthesis, and then you have uptake of CO2. This is what can be average on the general cycle. So from the figure below, before, you can see that there is respiration during the night, and then strong uptake during the day in summertime. And for several months, we have approximately the same level. So we have a lot of data of fluxes that will allow to validate the model afterwards. So about the directly use of the observations, so the researcher of the German team, they also showed some aspects linked to how behaves the energy water fluxes linked to the water content in the green roof. So they showed that there is a threshold in water content above which it's not necessarily pertinent to irrigate more because there is no more effect on evapotranspiration, while for low water content you have a direct relationship between the availability of evapotranspiration and the water content. Then about green walls, so these are two new sites. These are green facades, and there are four facades and four types of plants on the facade. Instrumented since last May, so it's very new measurements. And then we will have also measurements on the roof, but also measurements at the leaf level, measurements of radiation on the between the vegetation and the wall, between the vegetation and outside, and so on. And there will be some leaf area index, so the content of leaves of each type of vegetation that will be done at regular intervals. So about the modeling, so there are some needs to include this new modeling, these new processes linked to green walls. So we have a vegetation scheme that allows us to simulate the energy balance of vegetation, but also the CO2 photosynthesis and the evolution of vegetation linked to carbon uptake. So we will use this vegetation scheme, which is by AGS, but it has been validated only for natural covers and not for typically greenhouse, as we will see. And so there was very early results done by Aurélien on this greenhouse on Berlin on several years, and we see that the model overestimates the uptake of CO2, so the photosynthesis and the sequestration of CO2 by the greenhouse. So this is probably because the vegetation that is used in the model, for example, is for the moment typical of tropical grass, while it's herbaceous vegetation or sedum that you have on the roof. And we have to adapt the model and the characteristic of the vegetation in link with biophysical processes in the plant to be able to better represent the vegetation evolution, but also the CO2 fluxes. So this is an example of what happens on a long period. So there are some effect. So with the model, we are able to simulate the effect of the dry spells during the period, where you have much less evaporation and much less photosynthesis, as you can see in the observation, but we have more of this in the model. So we have to understand why the model is a little more sensitive to dryness. and also to correct the overestimation of CO2 uptake by the vegetation, by the use of sedum. So this is just also an early overview of the evolution of the leaf area index. And we see that this evolution is particularly good for a first start of the modeling. So we will try to improve it to make a better link with this and the CO2 carbon uptake in the plant. But this is encouraging for the following of the study. And then, so this was for green roofs, and there will also be modeling activities and validation for green walls. So, as a conclusion, the project will give a unique data set on green roofs and green walls. So the project just started 6 months ago, so it will stay there for during 3 years. So probably that you will have the results at the next ICUC. And we are still in the, so do not hesitate to contact the PI of the project if you want more information. And thank you very much for the talk. And if you have any questions,
thank you very much. So, any questions or